let's start this presentation with a few quotes. So, the customer is always right. It's a very popular saying. In fact, it's so popular, it has a Wikipedia page of its own. And then on the right, you have Mr. Jeff Bezos, the founder of Amazon, who says, customer obsession is not always listening to the customer. This dude knows a little bit about running a company, right? So, which is it? Well, in my relatively short experience at Scythe Robotics, I've already seen that it's a mix of both. And yeah, this talk is all about how we, the team at Scythe, basically find a middle ground between these two different schools of thought, especially when it comes to feature development. How we'll go about this presentation, actually look around here, I can't see this. But yeah, we'll go about this presentation by first introducing the product, we'll introduce the feature development process, and then go over the individual steps and finally finish it off with a few conclusion slides. Let's begin. So meet M.52. M.52 is Scythe's fully autonomous commercial lawnmower. How it works is, you drive the robot around the property that you want to mow, which you call the mow zone. There's a control panel on the robot where you can select the pattern that you want to mow in, and then press start and walk away. What happens next is M.52 mows that mow zone for you. This is the product that we're going to add the features on. And speaking of the word feature, the Google definition of the word feature is it is an attribute of a product that adds extra value to the customer. Scythe converts feedback into features to basically help the customers use our robot better. And we do that by following these 4 steps. Step 1, identifying a problem or opportunity basically to improve the product. 2, devising a realistic and achievable solution to address that problem. 3, getting it implemented, tested, verified, and deployed on the robot. And finally, 4, refining that solution until that problem is addressed. I want to repeat the statement I started with. Scythe converts feedback into feature. That's the name of the talk as well. But the word feedback, for an engineer like me, it takes me to the control system, feedback control system diagram, where you have a plant or a system, it has an input, and then it gives out an output. If you want to regulate that output, you measure it, and then basically feed that information back to a controller, and then which modifies the input to your system so you can get the necessary output. I want to propose that the customer-product relationship is very similar to this feedback control diagram. The customer is the system, and the input to the customer is the product that we make. And they use the robot. The company's objective is to regulate customer-perceived robot performance. Basically, we want the customer to be happy with our product. And we do that by getting feedback and then identifying problems. Then from these problems, we change our requirements so that we can basically address that problem. Then we get these new requirements implemented and hopefully provide a new and improved product to the customer and basically do it all again until the customer is happy. With this analogy in mind, let's go with step 1, problem identification. So first off, we need to measure the temperature in a room if you want to regulate it, right? So Scythe brings feedback from multiple avenues so we can detect problems from it. And these multiple avenues are here. We have the testing team that takes our robot out on the field and basically tests the software so they see problems before the customers ever would. Customers, if they see something off, they call support. That's another input to our feedback, basically. And the third one, account manager reports. We have robots deployed across 12 states in the US. Account managers are people who periodically reach out to make sure everything is in order. And yeah, their reports help a lot when it comes to identifying these problem points. We have customer demos and outreach. We reach out to potential customers who say, hey, if I had this one extra feature, it would be amazing. That's really good feedback. And finally, customer shadowing, where our engineers go out on the field and basically watch the customers use our product. So we bring in information from all of these different sources, and June 2023, from all of these information sources, the #1 customer feedback request was, we need a cup holder. A cup holder for an autonomous lawnmower. Well, it's not immediately actionable intel, is it? So I put this slide intentionally because when you look at customer feedback, you will see some information that you need to ignore or filter out just because of the nature of your business. We took note of this, and it is getting addressed in the next hardware revision, but we needed to look closer at the data to find some immediately actionable intel. And we saw a second pattern, which is sometimes the robot stops too far away. I'll try to explain this. At the time, how the robot the ending position of the robot depended on where you started the robot and what kind of pattern you chose to move. This image gives you a good description of the problem. First off, beautiful mountains, but you see a small rectangle on the right, which is enlarged, and you can barely see the robot in that as a circle. Scythe mows mow zones in area of more than 35 acres at times, and you're looking at, in the worst case scenario, a 30+ minute walk just to collect the robot after it's done mowing. Imagine doing that in the hot conditions of Texas or fighting alligators in the hot and humid conditions in Florida. We have seen alligators on our cameras as well, by the way, but yeah. So it is, one, a lot of fatigue for the operator, and two, it's a lot of wasted time. It's an autonomous machine, right? So we prioritized this as the problem that we wanted to solve for the month. Now that we have a problem, let's try to frame a solution. In Scythe, whenever we get problems or feature requests like this, the first step that we do is something called discovery discussions, where multiple teams, engineering, you have customer support, you have product development, and fleet management, field operations. A lot of people get into a bunch of brainstorming sessions where a lot of questions are put forth and addressed, basically on the hopes that answering these questions gives us a blob of a solution that we can implement. What you see is not even 10% of all the questions that were asked, basically, like what should these new home locations be added to the map? Can there be more than one for basically a property and so on? This next step is we usually categorize these questions or bucket them, and in our case, we had 2 buckets, which are, we know we need to go to some location, which we are calling the home location. Where is this home location and how is it set is the first bucket of questions. And the second one, how do we get to that new home location? So what we did, we put all of these questions into these buckets, and the next step that we usually do, and it works out almost all the time, is we apply this rule called the 80-20 rule, where we address 20% of the most pivotal questions so that we can provide 80% of the impact. So when we put these questions into these buckets, we also ordered them based on the priority. And we address the most important questions considering all the constraints we have. We are a startup, so we have time constraints. We have resource constraints. Our application has constraints of its own, and user experience, right? Taking all of these into account and answering these questions, we could find a pattern and these new set of requirements. One, record your home location where you start your task. So it kind of morphed into a return to start maneuver. Then travel home automatically after your mowing is done. The reason why we picked these 2 was it is lesser interactions from the customer. They don't have to do anything extra, and that usually helps with deployment. Go as close as possible to the home location. This is, again, easy to convey. I can say, hey, Mr. Customer, start the robot. Once it's done mowing, it'll come back exactly to that same spot. Easy to convey, right? And finally, you have do not bill the movement as mowing. The blades are going to be off, so we shouldn't be billing them the same way. With these new requirements, now we can start implementing. What we did was, first off, there was a change on the task level. We only had a mowing task. Now we have a new type of task called a taxi mode, where you're going to travel to a geolocation with your blades off. And yeah, so to solve a path to that new location, we needed a mission planner. If people are not aware of what a mission planner is, we have a hierarchical motion planning structure where you have mission planner at the top, which does not have a lot of constraints. Only thing is space or geometry, not geometry, only the space of the property. And yeah, then you have other systems underneath, like your collision avoidance for the next 10 meters, collision avoidance for the next 2 seconds, and so on. So we decided to put in a new unstructured driving mission planner, and we decided to also preserve all the lower levels because we could get a solution out the door quicker. And you can see the solution we have on the right. It's just a simple sampling-based planner, which basically goes like you sample a point randomly, and then you create a tree or a graph, and then you do this until you find a path to your goal. We also randomly bias the goal point as a sample point, just so we can encourage going to this path sooner. So we got this implemented, and you can see it working on the robot, where what you see is the mission plan for the mowing task, and the home location is on the bottom, the white dot. It finishes its mowing task, it finds a path, and then executes it. If there was an obstacle in its way, it would find a detour around it. But yeah, since we preserved everything underneath, we got this implemented in roughly 3.5 weeks. It goes to the home location and says it's done. All right, so we got this deployed on the robot. We had really, really good feedback initially. People were giving shout-outs because we saved a lot of time, right, and effort by the operator. Is there a refinement step even needed? Unfortunately, yes, because we started noticing a pattern after the initial round of applause, which was stray lines are ruining the aesthetics of our lawn. You can see on this image here, you have a really good mowed football field. I call it American football. I'm still Indian, so yeah. But you see that one line that comes in, that's basically the robot coming to the home location and stopping on this photograph. It seemed insignificant to the engineering brain in me, and so I ignored it for a few weeks. But it became unanimous across all the states in our company. So it is actually a deal breaker in the landscaping industry, the aesthetics of the lawn. In fact, it was so significant that the customers even asked, can you disable this feature? I'd rather walk 30 minutes to collect that robot. Please don't get stray lines. Even however small it is not acceptable. We were like, okay, now we need to adapt quickly. We did not know it was a problem. Let's go and fix it in the next 1 week. So a quick mission planner algorithm was swapped, which is what we call the mow zone contouring, but it's basically similar to a bug algorithm, where you're going to a goal, you find an obstacle, you contour the boundary of it until you reach the goal. It's a similar type here. We basically go towards the edge of the mow zone, and then once we're at the edge, we keep traversing the edge until we find a point, or we reach a point on the mow zone or the reach a point as close to the home location as possible without actually entering that mowed area. You'll see an example here. It's finishing its mowing task. You see the home location on the top. And yeah, the new path is basically on the outsides. It's never going to enter. And you see that gap between the home location to where the path or the mission plan ends. There you go. It finishes it. We got this deployed again, and this time we got shout-outs, and there was no more negative feedback, so we could safely say we had solved that problem that we wanted to address. All right, now let me take you back to that control system analogy. What you see over there is a step diagram response. The way we completed this feature was very similar to that. We made good impact with our V1, but we overshot it by a little. And then we had to quickly adapt to new feedback and get us back to desirable conditions. I would also propose that these control tuning parameters that you have on your step response curve could be used for your feature design decision-making process as well, especially for startups where you want to reduce TD or delay time, which is the time it takes for you to act on feedback you received. Then you have rise time, make impact towards your feedback as soon as possible. We'll skip the third one for a second. Keep overshoot low, in the pursuit of making quick impact, do not put something quick and dirty in there, which makes it overshoot by a lot, which makes it undesirable again. And then finally, reduce the settling time. Even if you overshot by a little, quickly adapt and get it solved. And yeah, everyone is happy after that. I want to conclude on the next slide with a few photographs that I would kind of say inspires humanity as a whole, if I could say it so myself. That is me on a motorcycle in the Himalayas, and that is me on a high-altitude lake in Colorado. It does not show a lot of relevance to the actual point I want to convey, but yeah. What I'm trying to say here is I'm an urban kid who loves to travel, and I have never owned a lawn in my life, even to this day. And I had never mowed a lawn before coming to Scythe Robotics. I do it a little more often nowadays, but yeah. What I do know is planning a path, a safe, reliable path between 2 points in space. And the nature of my job is every line of code I write, an operator is going to see the robot behave differently. How can I make a good product for a landscaper? Well, one, I need to rely heavily on good communication and collaboration between the multiple teams in our company. And two, again taking you back to the control system analogy, a good controller is built on a good model of the system. Similarly, I'd ask for robotics engineers to go out on the field and basically use your robot as a product so you can get a really good mental model of the application. It definitely helps you when it comes to taking decisions for your feature design. On that note, I'd like to thank Foxglove for having me here. I'd like to thank everyone for listening to me. I hope it was useful. Thanks again. Cheers.